In homework 6, we'll be going over functions. And the first one, you have two graphs, a function f and a function g. When you add your functions together and you replace x with a 0, with a 1, with a 2, 3, you plug in x in and find out what the value of y is for f, and you plug in f into g and find out what the value of y is. And then you add them together. And you can make a new coordinate and you can graph them. So we do this for 1, 2, 3, and 4. For 5 and 6, we are performing 4 operations on each of these. On each one of these, we're going to add them, we're going to subtract them, we're going to multiply them, we're going to divide them. For number 5, their domain started off as all real numbers. And it stayed the same domain until you hit the divide. What causes this change is this fraction. In the denominator, it cannot be 0. So x cannot be 3. So we take it out of the domain. In number 6, the domain is also all real numbers. And it stays that way until we get down to the divide. And this denominator causes us a problem. The denominator cannot be 0. So x cannot be 1, and we take it out of the domain. In number 7, we're given two functions, and we're going to take f plus g of 3. So when x is 3 in f, we plug it in. When x is 3 in g, we plug it in, and we come out with a 9. We do the same for f minus g of 0. Plug in the 0 into both functions, and then subtract those results. Be careful of this negative sign. In 9, you're multiplying the two results. So in f, plug a 6 in for x, find its result. In g, plug a 6 in for x, find that result, and multiply those two. In number 10, you're dividing. So put x of negative 5 into f, and negative 5 into the g, and then you'll get your result. In 11 and 12, we are doing composition of functions, and we need to find the rule. We do f of g of x and g of f of x. You plug the g into the f, then you plug the f into the g, and you come out with your rule. And you can see that these two are not the same. In number 12, we do it again, and we notice that they both come out to equal x. That is the same, and as we go into the next unit, we will find that these are inverses. Special conditions where they are inverses. In the last two, you're given two separate graphs. This one's f of x, this one's g of x. So in the first one, when we add f plus g of 3, we take the f function, we replace the x with 3, and it returns the 2. In the g, we look for the 3, and it returns the 1. And we add them. We do the division, and then we do two composition of functions. Always begin at the right. Find the result of g of 2, which there's the x of 2. It returns a 2 up here. We plug 2 into the f function. When we come to f of 2, we can see that it is a 0. Then we reverse this. We do g of f of 2. And after doing that, you can see that this is not commutative. It does not enable them to go both ways.